Okay. Okay, so is a recording voice is also okay? Okay. Yeah, sorry, I was thinking I still have 1 hour. That's why I got a break. Okay. So we have only 25 minutes, but I think the others I give you probably is a little shorter, so you still can enjoy it, but in the meantime, we'll still be able to finish. Okay. For the same student, Xiaoxin Yin, he actually got quite a few very interesting pieces of work. Besides this distinct, he got another one called Truth Finder. He got quite a few algorithms. That's why finally, when he got his PhD, he actually got an ACM CKDD dissertation award. The first dissertation award for this KDD community actually awarded to him. Okay. Of course, there are several others. I think last year, a year later, the award actually goes to Yuri Leskovic. Now he's a professor in Stanford University. So it's a really big honor to get this award. So when Xiaoxin came back from a summer intern, he bring back one interesting question. The question actually is a pretty tough one. The company actually told him, saying on the web, there are lots of conflicting pieces of information. You think about this. You got certain products. Some people may say, it's very good or something. Some people may dislike it. So you got different opinions. People study this opinion quite a lot because it's expected. But the key is sometimes when people want to find something really true or not, okay, just to try to verify the truth or validity, you probably see there are lots of different things people may not trust. For example, you look at the news, people may say they trust the news quite a lot, okay? But if you look at the people's website on blogs, the trustability actually drops quite a lot because your own blog, you can say whatever you like, whether it's trustable or not, it may not be quite, okay? So then we want to see what he brought back the question is, if you want to validate one statement on the web, is true or not, can we do it? Okay. That's a pretty tough question. Okay. And once he brought back, we were thinking whether we can find a good example. We really can judge what things is right or wrong, but people really have different things to claim. Okay, we found the bookseller. You probably know the bookseller. There are lots of booksellers on the web, like Powers Book, Barnes Noble. Nowadays, actually, there are more people buying books from the web rather than you go really to the bookstore. Okay. So, but if you look at this, you look at who are the authors of the book. He just picked up one called Rapid Contextual Design. Of course, it's not a very popular book. Otherwise, people probably would not really make mistakes. But what you see is those booksellers give different answers on the authors of the book. You think it's ridiculous, but it's true. Okay. And if you really look at the one, which one is right, of course, you can go down to Amazon.com, download the image, or you can even go to the Barnes Noble, the real, brick and the bricks bookstore. You go inside and look at it. That will not cheat you. Actually, we found there's only A1 books give the very right answer. Of course, Barnes Noble we cannot blame too much because this book is only missing the second author's middle name. Okay, but some actually people put like this. They put all the different authors and dash them. It's like a Spanish name, last name. That looks really, really strange. But anyway, if you got these different answers, can you judge which one is right? Okay. The problem is for those it's very hard even to train them. How could you train? You can say Barnes Noble must be right. Actually, it's not quite. So the problem actually is if you think you transform this one into a network, it becomes heterogeneous network because you got different websites. Everyone is a book dealer. Okay? You get the real objects, but they state who are the authors. That's the statements or stated facts. So you can see this O1 book actually was stated in two different facts, F1, F2, different author sets. Okay, which one is right? If you just watch this picture, okay, the picture definitely makes sense. Is you say W2, this bookseller says O1 was authored by F2. Okay, but W1 said O1 was authored by F1. They are different. Okay, can we judge just watching the graph? Can we judge which one is right? You first say that's hard because you look at this picture. There's no training. How do you know which one is right? Actually, by watching this picture, when we start discussing, the student actually seeing this picture, actually just to watch the picture, I can judge which one is right. Okay. The reason actually is we actually need a few principles we can judge which one is right. Okay. The first principle we said is we assume there's only one true fact. Okay. One true fact in many cases is not right because, for example, you say Barack Obama. So who is he? Of course, nowadays everybody say he is a U.S. president. But a few years ago, you probably won't say that. You probably say, oh, he was a senator or was a candidate, Democrat candidate or president-elect or something. So you will see different time you have different truths. Okay? But suppose we are dealing with only something like how high is Mount Everest, now, not just to say 3 million years ago. So you probably get only one. Okay. So then you get different thing, but just minor different version, like Jennifer Widom and J-Dot Widom. They are both right, but it just one is the shorthand of the other, you can say, a different way to express it. But 3 and 4 probably are the key heuristic we can use to judge. The rule 3 says the false facts on different websites are less likely to be same or similar. Okay. Simply says, if you say something wrong, different people say something wrong. When you're wrong, you usually tend to be wrong in many different ways. Okay. It's very hard the wrong thing all coincide. Okay. It's more like this. I quite often people argue on this. I said, suppose a police caught 3 thieves who stole a bank. Okay, so the first thing is you think the police were just get them together, say get a panel discussion on what happened. And never, police were not that stupid, right? So the police usually will isolate them, okay, and question them one by one. The reason is very obvious is without their internal communication, you just ask them to say, if they lie, they say something wrong, very unlikely will coincide. But if they finally find some piece of information they say consistently, that part tend to be more believable. But if they say 3 people say all 3 different versions, likely at least 2 of them are lying, okay, or none of them is saying truth. So that's usually we know is you're wrong. It's a random factor. It's very hard to coincide. Another thing, the 4th one, I think everybody will agree, is saying, website, if you keep providing true facts, likely the next time you say something, people will trust you more. Okay. Then by using this rule, you go back to this picture, you probably will find there will be something quite interesting you actually can find without anybody training you. Okay. Just think about this. At the very beginning, all the 4 information provider, all the websites you see, they have the equal trustability. You get the same trustability, same bar. Okay. But then you look at the network, you see this O2, these 3 things, W1, W3, W4, they all say F3. Okay. And F4 actually is only W2 said F4. So likely the F3, if they are independent, of course, you may say the 2 are the copycats of the other one. Okay. Actually, there are later studies on just dealing with copycats problem. Okay. So suppose they work out the answer independently, then F3 likely to be the right one, F4 likely to be the wrong one. Okay. Then you go back, you say F3 because W1 provided F3, W2 provided F4. So likely W1 probably a little more trustable. If the W1 is more trustable, you go down to this F1 fighting against F2, then F1 probably should get a better weights, get more credits than F2. So you actually can see this going back and forth, you can do something. You can judge, something can happen. Especially once you get thousands of books and hundreds of information providers, the trustability actually become cross-validating, many things can be right. Okay. So we take this as a principle. We actually thinking initially everybody is equal. Okay. Then you set up confidence and facts and trustworthiness of the web information. You set as a two heterogeneous things, they link together. So heterogeneous type, they link together. You are doing something like hits. You can think of PageRank like hits. You say some information provider, some authority page, they start validating, enhancing each other. So the same thing, we start enhancing each other, but not on the weighted score on the reputation, but on the trustworthiness. Of course, the formulas will be different. Okay, so essentially is you justify them differently. Then what you can see here actually is you look at this. We compete with Barnes Noble, okay, because Barnes Noble is ranked #1 according to Google. So then we compete with Barnes Noble. You actually see we randomly pick up from the 1,000 books. We randomly every time pick up 100 books. Okay, then we judge which one give you more correct answer, which one has more missing author. You look at every entry. Actually, this Truth Finder can beat Barnes Noble. Okay, it doesn't mean this one is magic. We actually know nothing about books. We just take a network. We take Truth Finder as one part of it. Okay, and we take Barnes Noble as one part of it. But we have hundreds of information providers, so they cross-validating each other to get better information. Okay, we actually can even rank the different bookstores on their trustworthiness on providing information about authors. Well, actually, these bookstores, they are highly accurate. They are no-namer. Okay. The reason they are no-namer probably is they provide, among these random pick of books, they provide less books. They're probably a little more specialized and a little more careful. Okay. And Barnes Noble actually give most of the books, 100 books, they give 97 books information, but it's not that accurate. But Powers book even give less books, but less accurate as well. So that's definitely the quality of the work, it does count. So this is about Truth Finder. Actually, after our study, there are quite a few people working on this, saying, how about the information changes? Or how about people have different versions? Everything like a Democrats and the Republican, both could be right. You don't judge them, but you finally say there are two centers or something. And how about the copycats? Okay, there are quite a few studies on this. Okay. Then another interesting thing is role discovery. Role discovery, the general philosophy is this. You get an information network. They all link together. It's like this one is a communication network. It's very messy. Okay. Just look at this communication network. You probably say, nothing I can find, because these are just nodes. They have so many different links. But if you do some cleaning, you do some kind of, look at structures, you probably can find, for example, okay, if you want to find a terrorist network, you want to find a chief, say, suppose this is bin Laden, this is some insurgent. The communication, actually, you will find is even this insurgent indirectly listen to bin Laden. You will not directly communicate with him at all. Okay, he was hiding very deep. So the key is there are structures of communication. Okay, you will not directly communicate to even to the cell lead. They have layers of communication. Finally, you layer out their structure, you probably can find it. Okay. We use this philosophy. We are studying about advisor-advisees. Okay. It simply says, take DBLP network. We just give some very simple heuristic. Say who likely could be an advisor, who likely could be an advisee. We take two key commonly accepted constraints. Okay. One says at the time of supervision, Usually the advisor publishes more papers than advisee and has a longer publication history than advisee. This usually should be true, right? You think about this. If you follow somebody publish much less paper than you, you probably will be hesitant even to follow this guy, right? Another thing is we say once the advisee becomes the advisor, okay, he or she will not become advisee again. You probably also will recognize once you become a boss, you don't want to, to become advisee again. So there are some exceptions, like actually in computer science department in UIC, we got a retired professor become a student, but not on the same topic. He became a law student, later become a lawyer. Okay, so that's different because it's not a publication record in law school. It's not inside, right? So, but anyway, what you see is these two commonly accepted in any country, these advisor-advisee rule should work. Okay, we put this one rather than you say must follow this guy for 5 years. Okay, what about 8 years or 10 years? So that's a different story because some people actually graduate in 2 years or just start publishing already graduated, right? So we take this, we actually constructed the network. The network actually is everyone has something on like years, a number of papers, and all these put it inside and start using the graph model to propagate it. I don't have time to get it, but I just say we do have some training. With this, we use some training. One training actually we use is mass genealogy. The other one is AI. Okay. Then the interesting thing I probably can show you is this. Okay. For example, you probably know Michael Jordan. Okay. You know David Blay, who actually is a professor in Princeton. This is a professor in UC Berkeley. Actually, we found who are David Blay's advisor. We actually found two. One is Michael Jordan. One is John Lafferty. Okay. Actually, the real truth, these are the years we found. Okay. The real truth is here. Real truth is Michael Jordan is David Blay's PhD advisor, and Blay actually graduated in 2004. But this one says 01, 03. And this 05, 06 actually was postdoc. Okay. But the year is almost the same. So you actually can see you find two advisors, both are advisors, but just at different stages. Actually, I got my own student, Hong Cheng. We tried her. We got two. Actually, one is a master because the year is pretty short. The other is PhD. That's actually all are accurate. And we actually took Serge Brown, who was Google co-founder. He was a PhD student in Stanford. We do not, of course, the data does not say that. But we found actually this 97, 98 was following Rajiv Modwani. Actually was true, but just saying as just he found a page rank and do not bother to get a PhD, then left. Okay. So that's a role discovery. You can find certain roles using constraints. Okay. Using simple constraints, but propagating in the very big gigantic network, they cancel each other, validate each other, so that finally you can get something quite interesting. Then another thing is PathSim is a similarity search. Okay. Similarity search, the general philosophy is this. Okay. This one actually was just an accepted paper in the VRDB conference. The similarity search just say who is most similar to Christos Volusus, okay, so for this question. This question actually is hard to answer because you take Christos Volusus, even ask him, he will say it depends, okay. It depends on whether you say similar means we co-author together, or similar because we publish in the similar conferences, or we work on similar topics, okay. So actually we found is if you want unambiguously in the network to identify similarity, similar objects, you need the schema-based paths. Okay. We take those schema-based paths here. What you can see is this paper linked with term, conference, and citing each other. This is author. We take this as our schema. Then we found if you follow the path APA, because author, paper, author, you just do this. Actually, this path more indicated co-author relationship because they share same paper. So we found that Christos Phallosus actually is the most similar people. Authors are Spiros Papadimitriou, Jimeng Sun, like Yuri Laskovic. All these were his students. Okay, so you actually can see because they co-author papers. But if you use the other paths, you say APCPA. It simply said, why we go so many? Because you go symmetric. You go to APC, finally the link is still have to go to the author. That's why we go to author paper, conference paper, author. You go through the conference. That means you share a lot of similar conferences. So you actually can see Christos Phallosus, the most similar one is me, Rakesh Agarwal, Jan Page, Agarwal. These are not necessarily co-authors, but actually we publish in the similar kinds of conferences. So and publish many in the similar conferences. That's the reason we are most similar. Okay. So this one, you actually go to, say, Flickr. You give a picture, say, which pictures are most similar to this? Okay. The interesting thing is we tried two different paths. One is just to say tag image tag. That means it's an image tag image. That means you just look at directed tag. If you just look at directed tag, you will get some similar thing, but some are not so similar. Like this top 5 is a bird. The bird is definitely not similar to the lotus flower. But probably somebody doing the tagging, they use similar tags somehow. So then finally you get, even they are not most similar, but rather similar to the lotus flower, which could be ridiculous. Maybe it's because of the location or some other things. They may say lovely or something, they put it down there, right? But if you go down, not only go down to image, but you also go down to group. Okay, you can see we use the image tag, image group, tag image. That means we go through the group. Then you actually can see the group tag plus the image tag together. You can get a rather accurate. Even you look at the same number 5, they have different colors, very different colors. But this one actually is also a lotus flower, but just not blossom yet, right? So this is really very similar. Okay. So using this, we can get something very similar. Okay. The last one I probably want to tell you is a past predict. Past predict means that's exactly Christos Phallosus gave me the question is, can you predict what papers I'm going to write? Okay. So I brought this question actually down to my students. We say, there's something we can work out, because if we know how to judge similarity, what about we judge the future links? Okay. To judge the future links, we actually studied this. We found past-based similarity is very telling. Okay. For example, if you want to say, I give you one question, could be judge who you are going to co-author with. Okay. Who you are going to co-author with, you can see this author, actually co-author means writing papers together. You have this link, you have a venue link, you have a citation link, you have topic link. You look at so many different links, you say which one counts? Which one counts more, which one counts less? This is definitely a valid question. Actually, you, based on the previous known facts, you actually can justify which links will count more. So we actually look at those possible links. We work out all the different lengths. This is length 4, 1, 2, 3, 4. This is length 3. We take length 2, 3, 4. We look at all the possible links like this. Okay. For example, this one is a paper cite papers. This is a co-author paper. This is, you cite this paper, you are going to co-author with this. Or some people cite you, you are going to co-author with. This is published in the same venue, you are going to co-author with. We take all these possible links. Then we do the study using statistics. We use the different measures. We actually later show you which measure will be better. Okay. But the interesting thing is we found if you take a heterogeneous network, you look at all the different things, what you actually will get is this. Okay. This is the p-value. Okay. And some p-value very small simply says that actually their link is pretty tight. Simply say you can use this one to judge this significance is more. But those links, those p-values pretty big, actually is useless because it doesn't contain much information. So we use this significance level, take this as a count. We do the training. Then the interesting thing you can see is we took all the possible candidates. Of course, the candidates you want to judge, you have to rank them. So finally, the interesting thing is I took one example. It was my student, Jiawei, because we judge him based on his before 2002. Then we judge 2003 to 2009 what author he's going to co-author with. Okay. The interesting thing is that before that, he was a student. So the existing link was very small. It's almost a link with me or with several authors. And this, he just graduated and started co-author with others. So the link to branch the co-author chance is high. We took top 5 ranked ones and found 4 of them actually was true. Okay, that simply says we only look at the paper published before 2002, like 1998 to 2002. Then we'll predict in 2003 to 2009 who he's going to co-author because we have the real data to test. The interesting thing is the top 5, the only one who did not co-author was his classmate. Okay, was the same advisee, of me. He's also a professor. But they too probably during the PhD study may not quite like each other. I don't know what's the reason, but they never co-authored. But all the others, a little branch far away, they do co-author. Okay, so that's interesting. And actually my student predicted me the top 10 and found at least 2 are right. The third one actually not in 2009 co-author, but the co-author in 2010, not count. The interesting thing is the Christos Philosophus, we never co-author a research paper, but we co-edit a book. That doesn't count because it's not in the DBLP. Okay, we do have some co-authorship, co-editorship at least. So that's the one. I probably think the time is there. I will not give you more. Probably I just show you the last one is we want to do this one on the web scale. Okay, in the real data on the web, like for example, we use this link. We first is try to find, give me one homepage of any department. You want to find all the homepage, no more, no less, all the professors in the same department. Okay, so and the student developed a very smart algorithm. The interesting thing is, I probably can show you one is you probably know the football. He actually take the basketball and football. He tried it. He took Illinois, one football player, and just on the web, he found the football of 10,000 football players, and 100% recall, 100% accuracy using this link information because they are structured. Okay. Then the interesting thing now he's doing is he actually took all the computer science US universities. This one he actually tried 25 top departments, get all the home pages of those professors. Now he's constructed using information network, construct a big information network, dig through the web, and try to construct a gigantic computer science knowledge base. Okay, so that's very interesting, but everything is automated. And he actually now is doing demo of his system, which actually he is in Athens doing the demo of his system. The system is still under development. In the future, we will make it public, everybody can play. The interesting thing, I think the most exciting thing is you don't need too much training. Okay, it's very little training. And you construct this information network, they actually enrich by themselves using this network mining methods. And then, the knowledge base can be constructed. So that's a very interesting thing. But anyway, I probably can say the very final thing I want to say is, the information network, especially the structured heterogeneous information network, is easy to get, but it's very powerful because from this network you can derive many, many things originally you think you cannot. Okay, especially like a DBLP, we all use it. We did not know it contains so rich information, and with this methodology, you can dig things out. Okay, so I'm done. If you are interested, you can go down to the website, download the many papers. If you want to search keywords, you go down to my site, you just say information networks or something, you can get lots of papers. Okay, thank you. So I think, I don't know whether we have time to answer 1 or 2 questions. Hopefully, we can get something really quick. 1 or 2 questions, we can get it done. Any question? Yes?
Is there some reason why you use the star representation versus something like
Yeah, the question is, what is the special reason you use the star network? Okay. The reason for star network is you have some center objects which link to many things, which to that extent, the links is very concrete. For example, you take the paper, you link to particular keywords, you link to particular authors. Those are very, very concrete links. Okay. And that center link many things actually is critically important. Just give you one example. We study NASA aviation incident report system. You know, aviation incident means you get any incident or any minor thing wrong, the pilots or maintenance people, they will say something, they put it into a database, you can search. Okay. But the unfortunate thing is they want to keep things confident. They take this incident, they got all the IDs, person ID, you know, the airport ID, the flight ID, the aircraft ID, all removed. Okay, other information was still there. But you don't have the critical link. You even do not know whether that's the same incident, it's just 2 people reporting exactly the same thing. One is pilot, one is maintenance person, or even you know, some other people in the same airport, you do not know at all. Okay. If you do not know this, what you do is more like a keyword-based search. The information, the valuable information to analyze this incident actually become very minimal. Of course, we cannot handle this more. They said it's confidential, you just cannot get this link. But without such links, the power like this, you cannot get it. Okay, so the link is critical. Yeah. Any other question? Yes?
In a star schema, how do you select the target object? Why do you select the paper as the target object? Why not the author?
I see. Yeah, that's actually the question related to that one is you got a paper because the paper directly linked to all the different things. That's the center of the universe. Because the paper linked to authors, linked to keywords, linked to the venue. Those are the critical links. If you take author, the author may use many, many different keywords. So the link, there are many variable links. For example, you work with this author using this keywords. You work on another paper, use different keywords. If you don't take the center one, you just take an author as the center, some information you collapse, you lose lots of valuable information. That's the reason. The reason we keep this target or center object is try to keep the maximum links you can get. Okay, the link is critical because without such links, the information you derived actually is somehow could be, you know, like just because you project you lose so many links, you may not be so smart. Okay. So because of the time, I will not answer more questions. Feel free, I will still be here until after lunch. You can chat with me anytime you like. Thank you.